Now we have come to quadratic equation. What do we mean by quadratic equation? Quadratic equation is an expression where we have the power of x or y or whatever to be 2. You know, in linear equation, the power is 1. But in quadratic equation, the power is 2. And we have several things to look into it. That's why we handle it as a subtopic. So, quadratic equation is always an expression like this: ax squared plus bx plus c equals 0 or whatever. And the simplest way to derive quadratic equation is multiplication of two linear equations. So, sometimes we have expression where our coefficient of x squared is 1. Let's start with that. So if we have the coefficient of x squared to be 1, and we have an expression like this, it's going to be x squared plus b over a x plus c over a equals to 0. Let's just make it like this. That this is what the expression will look like. Then, if it is factorized, that is into two linear equations, that I multiply to get this, I'm going to have something like this: x minus alpha and x minus beta. Yeah? This will be factors. X minus alpha, x minus beta are factors. And alpha, beta are roots. We refer to them as roots. Why? If you should put in the value of alpha into this expression, or into this expression, it's going to give you 0. If you put the value beta into this expression, or into this one, it's going to give you 0. That's why we say it is roots. Is that clear? Now, since I have this one, the product of this one to give me this, let us expand this. Like we did the other time, we are going to have x minus alpha and x minus beta. So I'm going to have this. We have done this one before. I just want to do it again. X squared minus alpha x minus beta x plus alpha beta. You can see. So at the end of the day, this product is going to be, that is, x minus alpha into x minus beta will be equal to x squared minus alpha plus beta x plus alpha beta. Now, if we equate this one and this one, you will see that b over a equals to minus alpha plus beta. C or alpha plus beta is equal to minus b over a. Here b is the coefficient of x. So c over a is equal to alpha beta. That is the product of the two. What does this one teach us? It is teaching us that if you have an expression of this manner, you have this. You have this. So when you want to factorize this expression, what are you going to look for? You will look for two numbers whose sum is b over a, and two numbers whose product is c over a. I hope it is now clear. You will look for two numbers whose product is c over a and whose sum is b over a. Get that? Once you get that, you'll now be able to say, okay, this will be the sign, maybe positive or negative. Why am I not emphasizing the sign yet? Is that by the time you work it out, you will reason out the sign. But this sign can be positive. When alpha, this one is minus alpha, this one is minus beta. It can be positive, it can be negative, either of the two. But by the time you resolve it, you will get your answer. Now, look at another situation. Most times, you may not have the coefficient of x squared to be 1. So, what do we have? We have expanded this to be x minus x squared plus b over ax plus c over a is equal to, okay, we expanded x squared minus alpha plus beta x plus alpha beta. Now let's multiply 2 by a. Let's multiply 2 by a. So what am I going to have? Ax squared plus bx plus c is equal to ax squared minus ax, a into x alpha plus beta x plus a alpha beta. Since I've gotten it like this one and this one, you can see you can easily handle that one. So you can now see that b is equal to minus ax plus a alpha plus a beta minus a alpha plus a beta, and c is equal to a alpha beta. Now, what is the product of a alpha and a beta? A alpha into a beta will be equal to a into A alpha beta. Are you getting something? So you can now see that, but C is equal to A alpha beta. Therefore, A alpha into A beta is equal to A times C. A times C. Therefore, when you want to factorize this expression, the first one, this one, what you need to do is to find two numbers whose sum will be equal to B and whose products will be product of A and C. I am talking about when the coefficient of x squared is not equal to 1. You will look for two numbers whose sum is equal to B and product is A. That is how we factorize the first one. But the second one, where the coefficient of x squared is just 1. What you just need to do is find two numbers whose sum is the coefficient of x and whose product is the C, the constant, and that solves it. I just deliberately made it like this so that you know that this one can be interchanged to this and this one can be interchanged to this. That's all. So from here, it means that we can easily carry out our factorization conveniently. Now let's solve these ones. I have number 1. X squared plus 11x plus 28 equals 0. So in this situation, you find the value of x, that is the root of the equation, or the factors that make this equation to be 0. We do the same thing for the second one. Yeah, we have 2x squared minus 3x minus 12 equals to 0. And the third one, 3x squared plus 14x plus 8 equals 0. Now let's do the first one. We have x squared plus 11x plus 28 equals 0. Now, we look for two numbers whose sum is 11 and the product is 28. Please take note. The sign must also be considered in this situation too. Two numbers whose sum is 11 and whose product is 28. So we have 7 and 4. So I can conveniently write it out like this. X squared plus 7x plus 4x. You know, this two combo makes up 11x. Plus 28 equals 0. If you look at it, 28 times this part, that's 28x squared. 7x plus times 4x, that's 28x squared. So we can now see, in factorizing, we look for what is common to these two. So we have x into x plus 7 plus 4 into x plus 7 equals 0. So we factorize this again, we have x plus 4 into x plus 7 equals to 0. So these are the factors already now. The factors are x plus 4 and x plus 7. So the root, for us to find the root, x plus 4 equals to 0. So what value will we put into the equation for x to give us 0? So therefore, x plus 4 minus 4 equals to 0 minus 4. So x equals to minus 4. We have gotten that. So when we input minus 4 into this equation, we are going to have 0. The same thing occurs here. X plus 7 equals to 0. Therefore, x plus 7 minus 7 is equal to 0 minus 7. So x equals to minus 7. So x is either equal to minus 4 or minus 7. So that gives us the solution to the first one. Now let's look at the second one. We have 2x squared minus 3x minus 5 equals to 0. So in this situation, this number 2 times minus 5, that gives us minus 10. And the sum should give us minus 3. So what are the two numbers that when we add them will give us minus 3, and when we multiply them will give us minus 10. So that will be minus 5 and 2. So we can now say 2x squared plus 2x minus 5x minus 5 equals to 0. So you can see this one makes up this. So at the end of the day, I have 2x into x plus 1 minus 5 into x plus 1 equals to 0. So I can now say 2x minus 5 into x plus 1 equals to 0. So if I should put these equations through this procedure, I'm going to have x equals to 5 over 2 or minus 1. So you can do that. It's straightforward. Now let's try the third one. Let's try the third one. I have 3x squared plus 14x plus 8 equals to 0. So we now look for two numbers, like we did. What's the product of 3 and 8? That's 24. So which two numbers? 12 and 2. So we have 3x squared plus 12x plus 2x plus 8 equals to 0. So we now have 3x into x plus 4 plus 2 into x plus 4 equals to 0. So we now have 3x plus 2 into x plus 4 equals to 0. So these are the factors. Now, the roots. Passing n through that situation, you can have x equals to minus 2 over 3 or minus 4. So those are the answers. Minus 2 over 3 or minus 4. Let's look at another set of examples. Now, on quadratic equation, we might, most times, we are asked to find the roots. And we have seen one of the ways of finding the root is by factorization. Finding roots. is by factorization. Another way is graphical method. Graphical method. When we are talking of graphical method, it means that if, like, when we have to find the roots, we will draw the graph, and the point where it cuts this, the x-axis will be our roots. We are still coming there. Another way of finding the roots, and at the end of the day, factorizing, is using our completing the square method. Completing the square method. Or using the quadratic formula. Quadratic formula. So, what are these two methods? They are the same, but this one is derived from this one. Just like you derive the sine rule from Pythagoras theorem, and from Pythagoras and trigonometric ratios, and cosine rule. The same way, these ones are extracted and used in solving quadratic equations. This helps us mainly when our roots are not real. When the roots are not real, complex, or irrational number, generally. Irrational, generally, let me put it like that. So it really helps us. Really helps us. And when I show you this completing the square method, you will realize that the most important thing you need to understand is the perfect square. The knowledge of the perfect square of quadratic expression. I have written on this perfect square. When we have x plus a squared, what is the expression we expected to have as a result? X squared plus 2ax plus a squared. When we have x minus a all squared, we are going to have x squared minus 2ax plus a squared. So you can see the only thing that changes is the sign of the coefficient of x. That's the only thing that changes. Now, looking at this, if I have an expression like this, x squared plus 2ax, what will I add to this to make it perfect square? That is, to make it something like this. What will I add to it? You can see, for both of them, and this one too, x squared minus 2ax, what will I add to it before it becomes perfect square? All I need to add to it is a squared, a squared. And if you look at this equation prior to adding this is the only one that has a. That is the coefficient of x. That is the only one that has a. And the a is half of the coefficient of x. A is half of the coefficient of x. So for me to know what to add to get perfect square, all I need to do is half the coefficient of x and add to it. That's all I need to do. Half the coefficient of x and add to it. So if I have an expression like this, x squared plus 4x. To complete this square, what do I need to do? I will need to add 4 over 2 squared. You can see. If I have something like this, x squared plus 8x minus 8x, sorry. What will I add to this to make it complete as a square? I am going to add 8 over 2 squared. You can see, that is the only thing that you need to know about this. And I've said it before, whatever you do to the right hand side, do it to the left hand side, depending on you. Sometimes some people will add and subtract, or add to both sides, depending on you. Now let's look at certain examples of how to use our completing the square method and then derive the quadratic formula. Now, let's use completing the square method to solve this. The first one, it says 2x squared minus 3x minus 5 equals to 0. For you to be able to use completing the square method conveniently, you need to make this coefficient of x squared units 1. And that will assist you, seriously. But for me, to make it very easy, first of all, move this constant to the other side. How do you do that? 2x squared minus 3x minus 5, okay, is equal to 5. You don't need to be doing plus or minus again. Is equal to 5. With this now, you can now make the coefficient of x squared 1 by dividing through by this. So we can now say 2 into x squared minus 3 over 2 is equal to 5. You can see. Okay, x, sorry. You can see now. So I can now move this away like this. I can now say 2 into x squared. You know, when I want to complete this, I just need to have this minus 3 over 2 x. You can see, minus 3 over 2x. What do I add to this now? Plus 3 over 2 divided by 2, all squared. You can see what I did now, all squared. I have to do it here. And it's either like this. Since I have added it, you know it's not part of the equation. I either add it to it again, or I move it to this side. That is what I've done to the right side, I have to do to the left side. So it's going to be 5 plus, you know this 2 is affecting it now. 2 into 3 over 2 times 2 all squared. Please, I want you to understand it. This one is half of this, 3 over 2. So I have it. And then I have brought it to this other side. But I have to multiply this one by 2 again, because I have 2 here. Because I have 2 here. Another thing you can do is divide through by 2 first. I will do that one also. Divide through by 2. So with this, I have 2 into x minus 3 over 4 all squared. You can see the root of this 3 over 4 all squared is equal to 5 plus 2 times 9 over 16. But this is 9 over 16, so this is 9 over 8. You can see straight. Now, I can now say 2 into x minus 3 over 4 all squared is equal to, and so this is 9 over 8. 8 times this one is 45. That's 49 over 8. Now, let me divide 2 by 2 again. So I have x minus 3 over 4 all squared is equal to 49 over 16. Square, let me now square root both sides. If I square root both sides, I'm going to have x minus 3 over 4 is equal to plus or minus 7 over 4. You can see, plus or minus 7 over 4. So x is equal to 3 over 4 plus 7 over 4, or 3 over 4 minus 7 over 4. So you can see, this one is going to be 10 over 4. That is 5 over 2. 5 over 2. Or minus 4 over 4, which is equal to minus 1. So you can see, from the previous example, we have done this one before. I didn't really use this technique to solve it. Another way you can do it is divide through both sides. That's the easiest way for me. Sometimes some people say add it, subtract it again. Fine. Before you move it to this side. But me, this is the simplest way to look at it. Let me show you and this the way. Now, like this one now, then I'm factorizing here. I will just divide through by the 2 first. So that all this multiplying again here will not be necessary. Let me do it that way. You know, our mission statement is making it very simple for you to understand and to enjoy. So the first thing I would like you to do is move the constant away to the other side. And how do you do that? 2x squared minus 3x will be equal to 5. First do that. Now divide through by the coefficient of x. Because for you to use this technique, the coefficient of x should be 1. That's the advisable way for you to do it. So you have now x squared minus 3 over 2x is equal to 5 over 2. You can see. And I have shown you the other time. To complete this square, you have to divide the coefficient of x by 2 and square it. And what do you do? That is x squared minus 3 over 2 x. What is the half of this? That is 3 over 4. And then you square it. Plus 3 over 4 all squared. Since I have added it to this place, I need to add it to the other side too. It is 5 over 2 plus 3 over 4 all squared. You can see. So this one is now a complete square now. I can conveniently factorize it. So I can have x minus 3 over 4 squared. You can see. Compare it to x squared minus 2ax plus a squared. So this is the 2ax now. And this is our a squared now. Will be equal to 5 over 2 plus 9 over 16. Very simple, very simple. Now, this is where my work lies. The LCM is 16. So this will be 8 times 5, 40, plus 9 over 16. Therefore, x minus 3 over 4 all squared is equal to 49 over 16. Now, the next thing is square root both sides. So I have x minus 4 minus 3 over 4 will be equal to square root plus or minus 49 over 16, which is plus or minus 7 over 4. From this I can now find x. X will now be equal to 3 over 4 plus or minus 7 over 4. Therefore, x will be equal to 3 plus 7 over 4, which is 10 over 4, or 5 over 2. Or 3 minus 7 over 4, which is equal to minus 4 over 4. That is minus 1. So x is either 5 over 2 or minus 1. So you can see, we have done it before and we are using completing the square to do it again because we arrive at the same answer. This is very useful when it is not easy. When the value of x is irrational, we see how to test for whether the value of x is rational or irrational. Now the next one is x squared plus 8x plus 5 equals 0. In this instance now, our coefficient for x squared is 1, so very easy to do. You can now say x squared plus 8x is equal to minus 5. Then let's complete the square. We have x squared plus 8x. What do we add to it? 8 over 2 squared is equal to minus 5 plus 8 over 2 squared. We have to add it to both sides. You understand? So that the integrity of the equation will be maintained. So from here you can see that our equation is x squared plus 8x plus 4 squared is equal to minus 5 plus 4 squared. Straight ahead, I can now say this one to be x plus 4 all squared. The sign you put here is determined by this, the coefficient of x. If the sign before x is negative, this will be negative. If the sign before x is positive, this will be positive. But in every occasion, we are going to add half of the coefficient of x to complete the square. And this one is now going to be 11. Now, for the value of x, you have to square root both sides. So we have x plus 4 is equal to plus or minus root of 11. You can see. So x will be equal to minus 4 plus root of 11 or minus 4 minus root of 11. So you can see, in this situation, there's no way you can look for the factor and get the factor by multiplying and adding. There's no way you could have done that. So completing the square has saved us from that rigor. Now let's look at this, the last one. We have 4x squared plus 16x plus 3 equals 0. Just like before, what do we do? We first of all shift the constant to the other side. So we have 4x squared plus 16x is equal to minus 3. The next step is divide through by the coefficient of x squared. So we have divide through by 4. So I have x squared plus 4x is equal to minus 3 over 4. You can see, minus 3 over 4. Then, let's complete the square. To complete the square, we have to divide this one by 2. And that is 2. So we have x squared plus 4x plus 2 squared is equal to minus 3 over 4 plus 2 squared. You can see. Now, I can now form my square. X plus 2 squared is equal to 4 minus 3 over 4. 16. That is 13 over 4. Now, to square root both sides, I have x plus 2 is equal to plus or minus 13 square root of 13 over 4. So x will be equal to minus 2 plus square root 13 over 4 or minus 2 minus square root of 13 over 4. So you can see, there's no way I could have been looking for the sum and product that I'll be able to get that. Now let us look at solution by the formula. Solution by formula. This one is very useful. When you are too tired to be looking for the roots, or instead of using completing the square method, just come straight to this and you get your answer. The only thing is that sometimes you might be, specified to use the completing the square method. That's why you need to learn it. But this solution by formula, this quadratic formula is derived from the knowledge of completing the square method. Let's see how it goes. We have an equation like this: ax squared plus bx plus c equals to 0. Now, like we said, if you want to complete the square, what do? You move this to the other side. And that will be ax squared plus bx is equal to minus c. Equal to minus c. Then, the next thing is to divide through by a. So we have x squared plus b over ax is equal to minus c over a. After this, complete the square. Just like what we did in completing the square. You complete the square. So we have x squared plus b over ax. We divide this one by 2 and square. Plus b over 2a all squared. And we add to this other side 2. Plus b over 2a all squared. Now, from here I can form my square, perfect square. So I have x plus b over 2a all squared is equal to b squared over 4a squared minus c over a. And you can see 4a squared is the LCM of the denominator. So I have b squared minus 4ac over 4a squared. Now, let me square root both sides. So I have x plus b over 2a is equal to plus or minus square root b squared minus 4ac over 4a squared. You can see. So this one gives me plus or minus root b squared minus 4ac over 2a. You know, root of 4a squared is equal to 2a. Therefore, x can now be equal to minus b over 2a plus or minus root of b squared minus 4ac over 2a. And since the denominator is equal for both, I can write it out like this: minus b plus or minus root b squared minus 4ac over 2a. So that is the quadratic formula. You can learn it by heart. And anytime you have any quadratic formula, you want to get the roots, that is the formula you use. We have b is coefficient of x, a is coefficient of x squared, and c is the constant. You know, I was telling you, how do you know when you can find the factor, the root will be rational or irrational? This is the discriminant. That is what we use as discriminant. I'll tell you why. So we talk about discriminant now. This is what will determine if the root will be real, irrational, or equal. That is when we have perfect square. Look at this equation. X equals b squared minus b plus or minus root b squared minus 4ac over 2a. This is where we determine either the roots will be equal, irrational, real, or whatever. Why? If b squared minus 4ac is a perfect square, you have real roots. If b squared minus 4ac is equal to 0, you have equal roots. That is, you are going to have perfect square, equal roots. And if b squared minus 4ac is not perfect square, you have irrational. When b squared minus 4ac is less than 0, you are going to have what we call complex root. But when it is greater than 0, you are going to have real roots. And if it is perfect square, you are going to have rational roots. So that is why we call this the discriminant. Now let's use this formula to find the roots of two equations. Now let's quickly use the formula to solve this. The first one is 5x squared plus 12x plus 3 equals 0. So what is our a? 5. What is our b? 12. What is our c? 3. And you know our formula for x is equal to minus b plus or minus square root b squared minus 4ac over 2a, which will be equal to minus 12 plus or minus root 12 squared minus 4 times 5 times 3. Please, the sign must always be put into consideration. Over 2 times 5. And that is minus 12 plus or minus square root 144. This is 20. So that is 60. Minus 60 divided by 10. So what does that? Minus 12 plus or minus root 84 divided by 10. And that's going to give me minus 2.117 or minus 0.2835. So, if not for the formula now, we'll be going through stress to get these answers. Now the next one. We have 6x squared minus 8x minus 9 equals to 0. Please, anytime you have any equation, quadratic equation, where you are asked to solve for x, you must equate everything to 0, please. Before you continue, you must equate it to 0. Except under completing the square method, you must equate everything to 0. Either for factorization or for using quadratic formula. Now, A is 6, B is minus 8, C is minus 9. You can see. Therefore, x is equal to minus b plus or minus square root b squared minus 4ac divided by 2a. So in this instance, x will be equal to minus, minus 8, that is plus 8, plus or minus root of 8 squared minus 8 squared, that is 64, minus 4 times what is our a? 6. What is our c? Minus 9 divided by 2 times 6. And that's going to give me 8 plus or minus 64. 4 times 6, 36. So 4 times 6 times 9. That's 2 and 6. You can see this one and this one has made it positive. So plus 2, 1, 6 divided by 12. Which will give me 8 plus or minus. So square root 280 divided by 12. And what will this give me? Plus 8 divided by 12. That gives me 2.061 or minus 0.7278. So you can see straight and direct. So you need to practice more, and with this, I believe I made it look so simple, enjoyable, and fun. Now solve for t in the equation x equals t plus half at squared. Because of the availability of quadratic equation, we'll be able to do this with ease. So let's bring everything together to a point. So we are going to have half a t squared plus ut minus x equals 0. That's the first step. You have to make everything in this manner before you continue. Now, in our equation, the coefficient of c squared is half a, or you can multiply through. Either way, I can say it like this: at squared plus 2ut minus 2x equals 0. I can continue from here, I can use it like this. So from here, a is a, b is 2u, c is minus 2. Therefore, c is equal to minus b plus or minus root b squared minus 4ac over 2a. And from here, we notice our b to the minus 2. So we have plus or minus roots. What's our b squared? That's 4u squared. Minus 4 times, what's our a? What's our c? Minus 2. Divided by 2a. And what does that give at the end of the day? Minus 2u plus or minus roots 4u squared plus 8a over 2a. Now, I can still break this further due to knowledge of sorts. And that will be minus 2u plus or minus roots 2. So this is u squared plus 2a over 2a. So that will cancel this. So at the end of the day, c will be equal to minus u plus or minus root u squared plus 2a over a plus 2a over a. So if I had used this one straight, I would have gotten my answer without all this unnecessary division. But you can see the availability of the quadratic formula has made it possible for us to solve this combination. Now, let's go a little bit step. Let's go upwards. In this situation, we'll handle polynomials. Now, let's talk about polynomials. In polynomials, let's look at it from linear equation. When we talk about linear, you can see we have it like x plus a. The power of x here is 1. When we talk about quadratic, we are having something like ax squared plus bx plus c equals 0. So the greatest power is 2. But mind you, the powers we have with x, we are not having anyone as in power of reciprocal, or we are having it in raised to root form. That is what we have been having. So we don't have anything like x raised to power 1 over n or x raised to power root n. So we don't have any of this. Now, after quadratic, we are having cubic, we are having quartic, and so on and so forth. So when it starts from that cubic form, we refer to those ones as polynomials, that is having many powers. So we have cubic, we have, say, ax cubed plus bx squared plus cx plus d is equal to 0. You can see. Just note, you don't have this terms like this. In the same way, we can have quadratic. Here we talk about ax to the power 4, bx cubed, cx squared, dx plus e. So you can see, we have it in this way. Now, I have told you something. When we are talking about quadratic, we always try to consider it as multiplication of two linear equations. And from there, we'll be able to, whatever we get as the roots, we can input it into this and it will give us 0. The same thing applies to this one. So if you are talking about cubic now, you look at it as multiplication of three linear equations. You can see. So, or you can look at it as multiplication of linear equation with quadratic equation. You can see. So, it can have real roots, it can have imaginary roots, it can have complex roots. However, the same thing applies to quadratic. Quadratic can also be viewed as having roots in this format. So you can see, and you can also view it as multiplication of two quadratic equations, multiplication of linear equation with cubic equation. That is the simplest way to look at it. Now, I want us to be able to perceive it like, from what we have done, we have seen that you can add two polynomials. You can even add polynomials and linear equation. That is very straightforward. You can add quadratic and cubic equation. You can do that. Either way. At the same time, you can subtract any of them. You can subtract linear equation from quadratic equation, quadratic equation from quadratic, any of them. In the same vein, you can multiply. And then you can divide. So all of this will be looked into briefly. And before, by the end, you'll be satisfied about the treatment of the topic. Now, let's start from the simplest. If I have an expression like this, I talked about roots before. Root is when we always refer to roots when we talk about making this expression 0. That is when it crosses the x-axis. Now, if you have an expression like this, and you ask, what will you be told? Like, what will you be asked to do sometimes? The basic thing you can be asked to do is evaluating polynomials given certain value. So, in this instance, if I have to find f3, if you have to find f3, find f3. That is, what will be the value of this expression? If 3 is inserted or substituted for x. So, f3 will now be 3 into x into 3 raised to the power 4 minus 5 into 3 raised to the power 3 plus 7 into 3 raised to the power 2 minus 4 times 3 plus 2. So it can be positive, it can be negative, it can be minus 1, it can be minus 0, it can be minus anything, and it can be positive, like we are doing now. So once you see that one straight, this is what we do. We are going to have 3 times 81 minus 5 times 27 plus 7 times 9 minus 12 plus 2. So let's see what that one do. So this is f3 now. Assuming I can make it simpler to reduce the error and make it look so simple. What do? We resort to nesting. Nesting is like, so I have 2 here, plus you can see that x is common to all of them. 4, 7x, 5x squared, 3x cubed. You can see that this x is common to all of them. Now I can still break this one here further, and this will give me 2 plus x, so 4 minus this x will now cover this one plus 5x minus 3x squared. You can see it is making it simpler. With practice, you can do it as stretch once. Now, let's work it further. We can have 2 plus x into 4 minus x into 7 x into 5 plus, to 5 minus 3x. So you can see. So this x covers everything in this bracket. This x covers everything here as well. And this one covers everything. So you just make sure you note what you are covering with the bracket. So this one covers everything to this stage. This x covers everything to this stage. So you can see. So what do I need to do when I'm solving this? All I just need to do is to solve one bracket, continue to the next bracket. Let's see. If I want to find f3 now, it will be equal to 3 times 3 minus 5. You can see. So now I will multiply this one by 3 plus 7, and then multiply by 3 minus 4 multiply by 3 plus 2. So what does that give me? This one gives me 4. times 3 plus 7 times 3 minus 4 times 3 plus 2. So 4 times 3, that's 12, plus 7, 19. 19 times 3, that's 57. 57 minus 4, that is 53 times 3 plus 2. 53 times 3, that is 159. 159 plus 2, 161. So it's not compulsory you use this. In practice, you find this one very comfortable. But this one, I use it. This one I use mainly. This one I use mainly. Straight. Especially when calculator is available. But if calculator is not that available, this is very advisable and it's good to learn it. Now, since we have known how to evaluate our polynomials, we can add, we can subtract, we can divide, we can multiply. So let's try some as examples. Now, we have 2fx equals 4x cubed plus 3x squared plus 2x minus 4. And gx equals 2x raised to the power 4 plus 5x cubed plus minus 5, 2x, gx equals 2x raised to the power 4 minus 5x cubed minus 3x squared plus 4x plus 6. Now, we are going to perform some mathematical operation on this two. So, let us say we want to do the first one, fx plus gx. That is 1. 2, gx minus fx. 3, gx multiplied by fx. And 4, gx divided by fx. So, let's quickly see how we do it. We have done, this one is very straightforward, addition and subtraction. All you need to do is just to gather the like terms and add or subtract. Now, let's look at it. For me, I like to do it like this. 4x cubed plus 3x squared plus 2x minus 4. This one is 2x raised to the power 4 minus 5x cubed minus 3x squared plus 4x plus 6. So you can see, I deliberately arrange it like this so that the terms with equal powers will be upon each other. Now, since I'm adding, it's going to give me 2x raised to the power 4, 4 minus 5, that is minus 1, so minus x cubed, 3x squared, so that will be 0. 2x plus 4x plus 6x minus 4 plus 6, that is plus 2. So, the answer, fx plus gx is giving me 2x raised to the power 4 minus x cubed plus 6x plus 2. So, please, you can arrange it on a straight line. But this, I decided to do this for speed. Once you arrange like this, please put the signs into consideration and then the expression, the terms with equal powers, let them be on top of one another. Now let's do the subtraction. Gx minus fx. So what does that give you? 2x raised to the power 4 minus 5x cubed minus 3x squared plus 4x plus 6. This one is 4x cubed plus 3x squared plus 2x minus 4. Now for ease, sometimes for those powers that are missing, you can put 0 like this, so that you will know that you have arranged them in right order. Assuming this one does not have x squared, like this one now, doesn't have x squared. So if you are trying to perform operation with this one, you can write 2x raised to the power 4 minus x cubed plus 0x squared plus 6x plus 2. So when you arrange it in that order, you will be able to arrange everything without mistakenly putting one under the wrong one. Like if this one is not existing, you might mistakenly put this 2x under this 3x squared. So it's always advisable to do it here. And this one too, I could have done it like this too. So it will make it very easy and reduce the tendency of making error. Now let's do the division. This one will give me 2x raised to the power 4 plus 0 minus 5 minus 4, that's minus 9. Minus 9x cubed. Minus 3, that is minus 6x squared. 4 minus 2 plus 2x. 6 minus 4, that's plus 10. So you can see, very easy to do like this. Now the next one is saying that we must multiply. And that is where we have to bring in our, well, whatever technique you like to do. You might make it straight, you might make it in tabular form. But when you do it straight, you take each term to multiply everything in the other bracket. Now, I have gx times fx. Just like if we have done addition and subtraction on a straight line. So in this instance, I will have to do it like this. 4x cubed into 2x raised to the power 4 minus 5x cubed minus 3x squared plus 4x plus 6. And then I will do the same thing for 3x squared until I do for that's minus 4. But for me, I want to do tabular formats. So now I have something like this. So gx, fx, and I'm multiplying it. So what do I have as gx? 2x raised to the power 4. Please include the sign. Minus 5x cubed minus 3x squared plus 4x plus 6. When you are having positive, you might not include the sign. Now let's do this again. 4x cubed 3x squared. You can see these ones are positive. So here you have 2x and you have minus 4 here. Now you will multiply all through and then you will now be taking the like terms in terms. So what do I do here? This one is 8x raised to the power 7 minus 20x raised to the power 6 minus 12x raised to the power 5 plus 16x raised to the power 4 plus 24x cubed. So the next one now, I have 6x raised to the power 6 minus 15x raised to the power 5 minus 9x raised to the power 4 12x cubed 18x squared. Now for the next one, I have 4x raised to the power 5 minus 10x raised to the power 4 minus 6x cubed plus 8x squared 12x. That's positive. So for this one now, I have minus 8x raised to the power 4 plus 20x cubed minus 12x squared. Okay, sorry, this is plus. Minus times minus. Plus 12x squared minus 16x minus 24. Now, all I need to do next is gather the like terms. Terms with equal powers. And most of the time, they will be arranged diagonally like this. Like this. You can see. You can see. So, it will be very easy to gather. That's why I said, if there is any term missing, replace it by 0. Please. It will make your work easily arranged. It will make your work easily arranged. So, practice to discover what I said. Now, I have this one. It's the only one. So, gx times fx is equal to 8x raised to the power 7. For this one, minus 20 plus 6, that is minus 14x raised to the power 6. Here, minus 12 plus minus 15, that is minus 27 plus 4, that is minus 23 x raised to the power 5. For this one now, minus 8, minus 10, minus 9, this is minus 27 plus 16, that is minus 11 x raised to the power 4. For q, 20 minus 6, that's 14. 14 plus 12, that is 26. 26 plus 24, that is 50. So plus 50 x cubed. Now for the squares, 12 plus 8, 20, plus 18, 38, plus 38 x squared. Minus 16 plus 12, that is minus 4x. Minus 24. So that is the product. You can see, once you do it in this tabular form, it makes it very easy. You can do it, you can stretch it out, you can arrange it like our normal. That one is very similar to this. So I have shown the idea in quadratic or multiplication of linear equations before. Now let's talk about division a bit. When we divide a polynomial with another polynomial or linear equation which is having lesser power than it, like this one, its power is 4 and this one, its power is 3. So if we divide this one by this, we are going to have another linear equation, and most probably we will have remainder. But if we don't have remainder, it means that this one is a factor of this one. So if they have the same power and there is no remainder, it means we are going to have a figure as the answer of the division. So that is what thing you just have to put in your mind. Now let's look at how we do the division. We do it like we do our normal primary school division. Remember. Now let's do this one to practice the division. We have this as the quotients. And what do? Just like we used to do in our primary basic classes, we bring this one outside. Plus x minus 2. And we bring this one inside this place. 2x raised to the power 4 minus 5x cubed. Remember, minus 15x squared plus 10x plus 8. Sometimes you might do it and there will be remainder. Sometimes there won't be. Now, if we divide this one by this biggest power, we are going to have 2x squared. That is 2x raised to the power 4 divided by x squared. You are going to have 2x squared. So that's only 2x raised to the power 4 plus 2x cubed minus 4. Oh, sorry, this one is x squared. Minus 4x squared. You can see. Now, what do? I subtract this from everything that is up. What is that going to give me? This one will give me 0. That's the essence. Minus 5 minus 2. That is minus 7x cubed. Minus 15 minus 4. That is minus 11x squared. You can see. Then, this one, 2. Let me bring them down. For ease, let me bring them down. So, I will now be able to perform my operation with all this expression here. So, x squared in 7x cubed. That is in minus 7x cubed. That's going to give me minus 7x. Minus 7x. So, minus 7x times x squared. That will give me minus 7x cubed. Minus 7x times x. That will give me minus 7x squared. Minus 7x times minus 2. That will give me 14x plus 14x. Now, let me subtract this one from this one. So, minus 7x minus 7. That's not 0. Minus 11x minus 7. That is minus 4x squared. 10 minus 14. That is minus 4x. So, let me bring this one down. That's 0 plus 8. Now, let me do this again. X squared in minus 4x. That is minus 4x squared. That's going to give minus 4. So, this is minus 4. You can see. So, that one gives me minus 4. And then, minus 4 times x squared. That is minus 4x squared. Minus 4 times x. That will be minus 4x. Minus 4 times minus 2. That is plus 8. So, you can see. On subtraction, it will give me 0. So, at the end of the day, this one divided by this one is giving me this one. So, 2x minus 5x cubed minus 15x squared minus 10 plus 10x plus 8 divided by x squared plus x minus 2 is equal to 2x squared minus 7x minus 4. That's an easy way to look at it. This is the commonest way of having. Now we can conveniently talk about remainder and factor theorem, just to mention them. For remainder theorem, it states that if a polynomial fx is divided by x minus a, the quotient is a polynomial gx of 1 degree less than the degree of fx, together with a remainder r, still to be divided by x minus a. And this remainder r will be fa, that is the function of a. We have r will be fa, that is, it will be the value if a is substituted for x in the function. Now, what are we trying to say? If you have fx, that is function of x, and we are dividing it by x minus a, clearly, this power, the degree of fx will be reduced by 1 to give us gx. That's what it will give us, plus r over x minus a. Just let's look at it from our normal arithmetic. Look at this. 11 divided by 3. What does it give us? It gives us 3 plus 2 over 3. Or we can express it like this. 3 remainder 2. In the same way, we can also have something like this. Something over 5. What does it give us? 3 2 over 5. Or 3 remainder 2. You can see, this one gives us more information. And this one is giving us the same information like this. So if I have not been part of this initial process, this is the only thing I will have. That's what we are talking about. That when you divide this fx by linear equation, please note, this is a linear equation. It's going to give you by power less than, of this less by 1, and then there will be a remainder which needs to still be divided by this. Now, how do we get this out without much problem, without much stress? Let's see what it will be like. So, in essence, I can also express this as gx remainder r. But it's always advisable to think of it like this. When you want to calculate from this perspective. Now, let's multiply through by x minus a. So, fx will be equal to gx x minus a plus r. You can see. So that is after multiplying through by xa, multiply through by x minus a. So you can see. Now, let us now substitute a for x into the expression. Substitute a for x. I don't know what this one will be, so I might not need to do that one yet. But let me do it here. What does that give me? It gives me f of x equals to gx into 0. Can you see? Into 0 plus r. Sorry, fa. So fa will be gx a minus a. That is 0 plus r. Can you see? So which means that fa gives me r at the end of the day. So that is the remainder theorem. That is, if I am asked the remainder, I don't need to first of all go through long division to find it. If it is the linear equation that I'm using to divide, all I just need to do, substitute the roots into the equation, and then I will get my remainder straight and direct. Now from here, if I now divide fx by x minus a, if after dividing fx by x minus a and remainder r is equal to 0, then x minus a is a factor. It's a factor. So that is the factor theorem. So what are we trying to say? If I can substitute any figure for x in the expression of fx and it gives me 0, it means it is a factor of that expression. It means it is a factor of that function. That is all about factor theorem. So this part is just the factor theorem summarized. That's all. Now we have these two questions to answer. The first part says divide x cubed plus 3x squared minus 13x minus 10 by x minus 3. And we also asked to use remainder theorem to find the remainder when it's divided by, when we carry out this operation again. Second one says divide 3x cubed minus 11x squared plus 10x minus 12 by x minus 3. It now says the second part, use remainder theorem to find remainder when 3x cubed minus 11x squared plus 10x minus 12 is divided by x minus 3. Is divided by x minus 3. Now, so the second part says use remainder theorem to find the remainder when 3x cubed minus 11x squared plus 10x minus 12 is divided by x minus 3. Now let's start with the first one. We can divide straight. Let's do it like this. We have x cubed plus 3x squared minus 13x minus 10 divided by x minus 3. So, like we did before, x here is x squared. So we divide through. So this one will give us x cubed minus 3x squared. Now subtract. This one will give us 6x squared. So, let me now put it 6x. X is 6x squared, 6x plus 6x. Now, 6x by this is going to give me 6x squared minus 18x. So, 6 from 6, 0. Minus 13 minus 18, that's 5x. So, 5 here is x in 5x, that's 5. 5 times x, 5x. 5 times minus 3, minus 15. So, we can carry out the operation like this. 5, 0, minus 10 minus 15, that is 5. So, we can see our gx, our quotient is x squared plus 6x plus 5. Remainder is equal to 5. So you can see, in this instance, remainder is number. It's a number, not a function of x, not a linear function. Please take note. Now, if we want to find the remainder using the remainder theorem, what do we need to do? We just say fx is equal to x cubed plus 3x squared minus 13x minus 10. So, when we are dividing by x minus 3, it means that we are using f3. How do we get that one? X minus 3 is equal to 0. So the roots in this instance will be x equals to 3. Because what will be the value of x to give us 0? That's why. So in this instance, we are going to have f3. We are going to find f3. And you can do it straight or you can do it in nested form. Please, before I go on, I want to show you another thing. Assuming we have it to be x plus 3. the x we are going to use is going to be minus 3. So please take notes. Take note. Take note of that. So now, what do I have? You can do it nested form and you can do it straight form. For me, I like straight. So this one will be 27 plus 27 minus 39 minus 10. So that is 54 minus 49. And that is 5. You can see, I don't need to stress myself to go through all this. I get my answer straight. That's the joy of using remainder theorem. Let's go to the next one. Now, the second one, we have a situation like this. 3x cubed minus 11x squared plus 10x minus 12 x minus 3. So, what do I have here? 3x cubed. X is 3x cubed. That is 3x squared. Now, let me use that to multiply through. 3x cubed minus 9x squared. Now, divide, subtracting. Sorry. So, this will give me minus 2x squared. So, x in minus 2x squared, that's minus 2x. Multiply through, I'm going to minus 2x squared plus 6x. Subtracting, that will give me 4x. X in 4x plus 4. So what does that give me? 4 times 4x. 4 times minus 3, that's minus 12. Subtracting, gives me 0. So which means that x minus 3 is a factor of this expression. So that is, okay, r equals 0. Gx equals 3x squared minus 2x plus 4. Since r remainder is equal to 0, therefore x minus 3 is the factor of 3x cubed minus 11x squared plus 10x minus 12. Now, if I use remainder theorem, what will that be? Fx is equal to 3x cubed minus 11x squared plus 10x minus 12. So, it will be F3 will be equal to 3 times 27, that's 81. 11 times 9, 99. Plus 30 minus 12. So, this one will give me 101 minus, this gives me 111 minus 111. So 0, you can see. If I have to find the factor, all I just need is to input anything into fx, and then if anyone gives me 0, it means it is a factor. That is all it means. Let's read this. Just one of the applications of factor theorem. Show that x minus 4 is a factor of fx equals x cubed minus 6x squared minus 7x plus 60. And as far as possible, factorize fx into simple terms. Let's see how it goes. We have fx equals x cubed minus 6x squared minus 7x plus 60. We are now asked to show that x minus 4 is a factor. So, x minus 4 equals 0. Therefore, x will be equal to 4. So, we are going to find f4 now. That's what we are trying to find. We are trying to find f4. And that will be equal to 4 raised to the power 3 minus 6 times 4 squared minus 7 times 4 plus 6. And this can give me 64 minus 96 minus 28 plus 60. And this 124 minus 124. So which means that x minus 4 is a factor. We have shown that. Now, we are now asked to factorize as far as possible. The next thing is to divide this expression out with x minus 4. You can do it in two major ways. You can do it using this long division method. So, x cubed minus 6x squared minus 7x plus 60 and x minus 4. Now, x here is x squared. Please, your note, this x is first of all used to divide this to find the first term of the quotient. And this one is now used to multiply this one all through. This, so we have x squared times x cubed minus 4x squared. Subtract 0. Minus 6x squared minus 4x squared. That's 2x. Minus 2x squared. Again, x here is going to give me minus 2x. Multiply through, I'm going to have minus 2x squared plus 8x. Plus 8x. Then, this one gives me 0. Minus 7x minus 8x. That's minus 15x. X here is minus 15. So I put minus 15 here. Minus 15x. Minus 15 minus times minus 4, that is plus 60. So you can see at the end of the day, I have 0. So I have divided successfully. That's what it shows. Then I will now need to factorize this again. That's how to go about it. So how do I do that? I will make it like this: x squared minus 2x minus 15. Just like we do our normal quadratic factorization. Two figures that give me minus 5 and minus 15. That is minus 5 and 3. So I have x squared minus 5x plus 3x minus 15. And that will give me x into x minus 5 plus 3 into x minus 5. So this gives me x plus 3 into x minus 5. You can see. So at the end of the day, it means that x cubed minus 6x squared minus 7x plus 60 can be factorized as x minus 4 into x plus 3 into x minus 5. That is how you work it out. Straight. That's the final factorization. Another way you can use to divide this, when this one is linear, it's very easy. You can use it with any power, with any you can use it with any degree. The only thing is that the denominator, the degree of the denominator must be lower than the degree of the numerator. If the degree of the denominator is higher than that of the numerator, what we do sometimes is we do partial fraction. So that's another lecture entirely. Now let's look at another way you can divide. Now, I want to divide this expression, fx, by x minus 4. What do? I have already known the divisor. So what I know is, I know this one is going to be x squared. So this x squared, if I divide this one by this, so I have x cubed, I have it like that. X squared, just like the division sign. So that x squared, I use it to multiply the 4. Minus 4x squared. You can see. What will I use to make up this and this? So that at the end of the day, I have minus 6x. That is minus 2x squared. So you can see, these two combine to give me this. Now, I still have this. Look at this. So what do I need? So, yeah. So what will I do again to make this up? So I have 2x squared. So I use that 2x to multiply this. I have this already. That 2x again, I use it to multiply that minus 2x, sorry. I have minus 2x here. If I divide it with this. So that minus 2x, I use it to multiply this. So I have minus 8x. Minus 8x. Looking at this now, that minus 8x, what will I use? What will I add to it to give me this minus 7? Oh, sorry. This will be plus 8x. So this is minus and this is a minus. So I have minus 8x here. So that minus 2, I will use it to multiply minus 4. I have minus 8x. Now, what will I add to 8x or subtract from 8x to give me minus 7x? And that is, I'm going to add minus 15x. Can you see? Very straightforward. That minus 15x now. X in minus 15. That is minus 15. So that one is already there. That minus 15, let me use it to multiply this 4. That gives me 60. You can see, this expression is the same thing like this. Just like when you do it in quadratic equation. At the end of the day, I can now factorize it straight. Look at this. I have x squared into x minus 4. So that is what I use to generate that. I must have x minus 4 continually. In the next part, I have minus 2x into x minus 4. Can you see? In the next one, I have minus 15 into x minus 4. So this expression can now be x minus 4 into x squared minus 2x minus 15. I can now factorize this again. So which will be x minus 4 into, what does this give me? X squared minus 5x plus 3x minus 15. And you can now see into x minus 5 to x plus 3. So you can see. So depending on what you like, you can also do it like this. You can use this pattern even for quadratic. If you are divided by quadratic, if you are divided by cubic, but it might be a bit tough. Those ones, it's advisable you use the long method. But this one, once it is linear, you can do it straight like this. Let's look at another example before we go to the next level. Now look at this. It says solve the equation 5x cubed plus 2x squared minus 26x minus 20 equals to 0. Please, I want to know the difference. When we have fx, we might be asked, find the factor, factorize. So in this instance, what they are just asking us is, what will be the value of x that will give 0? So we are not asked to factorize, we are asked to find the roots. That's what you are asked to find, the roots. So you see. Now, you can nest it, or you can do whatever. Expanded form like this. The first thing we'll do is, we will look for figures that we can input into this. Once we do that and it gives us 0, that will give us our first step to climb. That will give us our first rung on the ladder. Because we are not like the last one I did, we are given one factor to start with. But in this instance, we are not given any factor to start with. So we need to work it out. And we do that by guessing. They call it so we refer to that as by trial and error. So once you try one figure and it doesn't give you the answer you are looking for, you try another one. So let's see. Let's next this. So you can say 5x cubed plus 2x squared minus 26x minus 20. We can also express it as this. 20 minus x to 26 minus x into 2 to 2x. Okay, sorry. Minus x into 2 plus 5x. So this one covers this. This one covers this. So if you look at it, 26x, 2x squared, 5x cubed. So this one makes it very easy for us to work anything. Now, if we make x to be 0 now, it means everything here will be 0. The answer is minus 20. 0 is not applicable. Let's use 1. If I put 1, this is, it means I have 7 times 1 minus 26 times 1 minus 20. So this one give me minus 19, so this one is not 0. Now let's look at 2. If I use 2, what would that give me? 5 times 2, 10, plus 2, 12, times 2, minus 26, times 2, minus 20. So what does this give me? 24 minus 26, that's minus 2 times 2. So this one does not equal 0. Now, let's use minus 2 equals to minus 2. I'm going to have minus 10 plus 2, that's minus 8. Minus 8 times minus 2. Now, minus 26 times minus 2 again. Now, minus 20. Let's what that is. So, this is 16. 16 minus 26, that is 10. Minus 10. Minus 10 times minus 2. Minus 20. That is 0. So, therefore, x equals to minus 2 is a root. It's a solution. It's a solution. So from there, I will now use this to divide this expression so that I'll be able to get the other ones. So we have established that x minus 2 is a solution, or x plus 2 is a factor. Now let's use this to divide this. We can use long division and we can use that straight division. So let's see. If I want to use that straight division, I just put 5x cubed plus 2x squared minus 26x minus 20 will be equal to, now I have 5x cubed here. So 5x cubed, because I have 5x squared to multiply this now, plus 10x squared. So what do how do I make this? So I have 5x squared to x plus 2 minus 8x into x plus 2 minus 10 into x plus 2. So you can see, so I have 5x squared minus 8x minus 10 into x plus 2. So I can now factorize this. And we have talked about discriminant the other time. If I realize that b squared minus 4ac is not giving perfect square, it means I can only solve it using quadratic formula or completing the square. Let's try. What is my b squared here? 64 minus 4 times 5 times minus 10. This one is 20, 200, 264. Is this perfect square? I don't think so. It's not perfect square. So, which means that I will need to use factor theorem to solve this. I have already established that x minus 2 is a solution. Therefore, x can be equal to 8 plus or minus root of a squared minus 4ac. I think we go down to 264 now. Divided by 10. So, x can be equal to minus 2 or let me use calculator to get that. So you can see, after solving now, this one gave me this, and this is the initial value we have. So x equals minus 2, 2.425 or minus 0.8248. Those are the solutions of this equation. So all you need to do is to practice more and just practice, that's all.